Delhi and Pakistani and Mr. Pakistan, at today this video I teach you how then make a smart trolley for shopkeepers. So this is a smart trolley based on RFID. So basically you market purchase something, shopkeeper can bring that thing to the scanner and then tell you total price, which price already minus your bank account of this price minus by your current price. Money which is in your bank. For example, there is a RFID tag. So there is I use 3 RFID tags. You can use 4, 5, 10, 20, 100 as you want. Arduino, SMD, then use any Arduino, no matter which nano, pito or any Arduino. RFID tag either which is a RFID RC522 16x2 display which I2C back module. This time this jumper is connected this module because my display is faulty. So I bridge this display modification so it is not a display part of this is a tag. And when I stand start, under the is minus, total balance is 500 and my remaining balance is 400, and it is also showing a serial monitor in the laptop screen. This time my laptop screen is not clear. So, and it is also the UID in the laptop because I am making this setup. You cannot connect the laptop because it only show the data error I am testing for just for testing. I also connect with the laptop. It is work directly with power bank. Also the same you can add under. Also you can under 150 now stand is curved. Then under the is also rotated. So this way you can put if stand more than that. So this is I set 500 rupees. You can set more than 5 or 10,000, 20,000, and you can set every card 150, 120, 220, 250 as set the amount. If stand more than that, so this is I set 500 rupees. You can set more than 5 or 10,000, 20,000, and you can set every card 150, 120, 220, 250 as set the amount of card and put change which change you can sell them and put this dart inside a bag. For example, I have a stack. I give you example in a stack. Let me wait. For example, this is a snap. I sell this snap. I am shopkeeper. I am selling this snap. So I know how much this price is this snap. So we basically scan this snap in the RFID tag. This is my already set below, but you can minus it by removing power or restart it, and then stand up your snack bag or which thing you can sell. Minus 100. So meaning it is also low minus because my value is already low, budget value is low. So you can set up reset this value and this stand is 300. Now this way you can use this. Although I open this bag and inside its battery is down. Inside I putting always inside this RFID card inside a bag which bag you want to sell it. And then you scan this person scan the bag and then it will count read this RFID card. Then also use this type of card also. Stand by this and this show in the display. Now show first sections. This display is backside as I2C module. For Arduino with SDA and SCL is connected to the analog 4.5 also. You can have analog 4.5, but I connect SDA to SDA, SCL to SCL. And this is RFID RC5200 which are connected 3 voltage by 3 volt, it's ground to ground, 3 volt to 3 volt. SCL SDA is connected 910, digital 910 and master in slave out and slave in master out are nothing. Master in slave out and slave in master out are nothing. I mean 10, 11, 12 or 11, 12. And this has been pin number 6. And this is when we come next to by the way, I explained the tone in the screen recording in the laptop page pause. Now explain the tone of this smart auto billing trolley system using RFID. As include SPI data library for SPI mutation. As include MFRC 5222 data library for RFID receiver. As include liquid crystal I2C data library for liquid crystal I2C display. Constant int reset pin 9. Constant int access pin equals 10. MRFC 5 to MRFC RC522 access pin reset pin. Total amount is 500 equal 500. So here set the amount, which amount you have, total amount which you can set here, which is crystal I2C 0 into 27 16 into 2 LCD display. So here we set our display resolution. In my case 16 into 2 display, you can use 0 into 27 or 16 into 2, both work. But I recommend you can use, if you have 0 into 27 digit display, then the resolution display, then that you can use 0 into 27. Because this display is little bit smaller, so that's why it will not show 16 into display. Is my display little smaller, which is 16 into 2, so it will not show all the data in same time. So that's why I will make a little bit changes. So if you want a bigger display, if you have bigger display, then it is also good, but still 16 into 2 display also be worked. White setup border 906 first see mutation with system LCD billion 16 into 2. Here we set display resolution. I am use 16 into 2. You can use 27 0 into 27 or 16 into 2, but you can define here which resolution you are use. SPI billion for SPI interface FRC 522.pd int PCD int, which is enable installation RFID card, CF in total amount, CF in line total amount, and here we do this line is blocked because this line is not working, so I block this line here. So this is extra line. CF print line, place RFID card reader, and then those white LCDs at the trussel, then last 0 into 1 in the while loop. And if MRFC522.PICC is new card per C, which will check the whether RFID card is new or not. If MRFC522.PIC read card serial. So if first line check if whether it's new or it's already registered. If second line is used to check whether the card is new, meaning it's not registered already, then it's CF in the card UID and for byte I equals I variable 0 I less greater than MRFC522.UID size I plus plus. So it will measure that I is variable, which variables contain already 0. It will measure the value, which value is RFID UID value, and store it to the I variable if it is not already stored it. So print UID in decimal 0 in edge 10, serial print MRF C522 U byte in edge. So it also print decimal value, also print at EH edge value in serial monitor. Serial print line, and then this if chat authorized star MR FC522.UID UID byte. So it will check whether the star is registered or not. First it will tell you, top position tell you, this line tell you the RFID star which UID your RFID star is, and this line match the UID to the initially saved UID it is stored, whether it is same or not. If it is same, then LCD print authorized start payment processing payment. Also print same time with serial monitor using serial print line, serial dot print line, authorized start processing payment, and this function starts all this function which is a process payment function, this function, and else if star is not UID is not matched to predefined UID, then serial print unauthorized start please register start first, and similarly print also the LCD print unauthorized start please register start first, and if authorized start delay one setting, this is a boolean function which checks star is authorized byte UID, and I define 4 UFIDs. If there's 4 UIDs which are 4 stars, you can add more than 100 UID which it can check match these. When I place the star, it will match the incoming UID with these predefined these values. These are RFID IDs here. So if anyone is matched, then it's do. Return true, else false. So this, otherwise, if any UID is matched, then this in the predefined value, this function is true. Otherwise, else false. Return false, else false. And then LCD clear. If any data already print, it will be clear. Then LCD set it also 0. It will do the back in the tussle, first tussle, and then in total those here, which is total amount, it was total amount 100. So it will minus the third amount, which is 100. The third amount is 100, which is minus by total amount, and then serial print trolley free declared from third balance equals 100. This time you can change 150, 120, 110 or 50, 20, 10, 11, 1000, 10,000, 20,000, 60,000, even more than 1 lakh, 2 lakh, 10 lakh, and more than amount you can set there. But this time you may be your total amount is higher than your minus or detected amount. So if you have select maximum low amount, minimum amount, and your detected amount is too high, then it will go in the minus range. That you can see in my video already. Serial print trolley free declared balance 100. Same time it will print this line in LCD print, but due to my LCD small, so it will not fit all the digits. So what I tend to do, LCD print trolley free, and then set the tussle, second tussle, meaning tussle do second row, first column second row, and then print again it print LCD dot print detected equals 100. So first row column number 1, it will print trolley free, and second row first column declared equals the 33 equals 100. Print and then delay from 1 second, and then LCD totally cleared. LCD dot cleared. Also LCD set it also 0. Also do back do 0 LCD print remaining. Then those are setting also do a setting 0. Then print LCD dot print balance. Then also do setting first setting row 10th column, because this time balance if you count the digit of this balance, so there are 10 digits like B L A B A L A N C E. So there are total 10 digits with plus this space, 9 digit plus 1 space. We also count this 1 digit space also as a digit, so there's total 10 digit, and we set 10 setting row 10 digit. After the 10 digit it will print the total LCD print total amount, it will print total amount, and also print serial meter like serial dot print total amount, and then finish it. And this video is when we come next to your solution. Pause.